Alright, I don't know what's going on here, but wallpaper engine ain't pausing. Come on, baby. You can do it. Let's go, wallpaper engine. Where the hell are you? Come on. Oh, man. Wallpaper. Here we go. 100%. Holy moly. What the heck? Okay, that. This is not normal. Alright, here we go. See what we can get done. Now, we have... Why can't I hear myself? Hello? I mean, it's coming through on stream, but... I can normally... Oh, that's better. It's just not loud enough. USB... Okay. I don't know what that... Hello? What's that volume balance like? Got some sexy sax going on in the background there. I'm not sure about it. Let's go DMCA 3. That's better. I just want some of that boring stuff. Okay. All right. Now, where were we? This was a... I'm not going to say it was a failure because it wasn't. We need to improve. We need to improve this. So I'm thinking the tooth profiles is one thing that we need to improve. They're just not good enough at the moment. So I think, while the module is okay, I think the shape of the teeth is not good. So we're going to need to parameterize some of these. Yeah, we're going to need to parameterize these. So I'm going to go 0.4 mil on the root fillet, 0.4 mil on the tooth fillet, and we're going to apply that to all of our gears. Head fillet, that's what it is. Wait, what did I call them? Variables. Head fillet. So we'll call that, what did I call that? Tooth fillet. We can rename that. Thank goodness. Variables root fillet. Now, okay, so actually the one thing that I need to consider here. Uh-oh. Alright. Yeah, basically I want these rounder and smoother, and I want them shallower as well. I need them way shallower. I think they're far too deep at the moment. Shallower they are, I think the better they're going to rotate, the less force they're going to be able to hold on to, but that's okay. It's not like it's going to slip easily. The rotor arm is very strong, so we don't have a problem there. I think I wanted to put on a duck, see what happens. Oh, there we go. Yeah, that's not too bad. Bit of a duck on the music, so. So that means I can turn it up and it's, yeah, it's not too bad. That's good. I like that. Right, so next we're going to... I need to match the... So what I'm going to do is... I'm going to rename these now. So I don't get confused. We're going to go rename property. We're going to call it Flex Tooth Fillet. No, Flex Head Fillet. and we're going to call it this one flex root fillet, and that's going to determine the opposite of the other gears. So the head, wait, yeah, the head, the root fillet of that is going to be the head fillet of the flex gear. So we're going to go internal involute. We're going to go the root fillet is actually going to be the flex head fillet size, and here the head fillet of the outer gear is going to be the root fillet of the flex. That makes sense. Yes. Yes, it does. Right, so we've done that for that one. I should really output rotor internal involute gear. I believe this is the... I have no idea what that is. Is that the cap? That's the cap. Output rotor cap. Datum plane is output rotor cap face datum. And this is a mount hole. Mount hole polar. And then we do a nice fillet. Output rotor cap fillet. Nice. Okay, so now all this stuff actually makes sense. Output rotor, output rotor origin. I don't know why I don't put spaces in some of these, but it doesn't really matter. Who cares? I don't at the moment. So we'll call this flex spline origin. Oh, part origin. Whoops, my bad. Flex spline body origin, involute gear. So we'll call this the flex spline involute gear. And then this is the flex spline inner diameter, we'll call it. That'll do. So the flex spline involute gear, what we're changing here are the fillets as well. So we're going head fillet, and this one's just straight on the variables. We'll go flex head fillet. This one here is variables flex root fillet. And that should then marry up once it recalculates itself. We go F5. That should then marry up with our new fillets there, and that should look a lot smoother than it used to, which it does. Now we've got this pressure angle of 20 degrees, which I was considering increasing to like maybe... We'll go angle, maybe, we'll try 25 and see what happens. We'll go through and pressure angle, variables, pressure angle. We'll go through and change all of these as well. I've still got to change the base gear as well yet. Flex spline involute gear. So variables, pressure angle, and I reckon with that, even that is going to make a huge difference to how smooth this runs. Fillet not possible. Output rotor internal involute. Yeah. So I wonder if that's the root fillet. Probably. So it's not going to match up with the tooth. So, in other words, what I need to do is reduce that, flex head fillet. We need to go back to like 0.2 and see if the fillet is possible there, which it is. Now, that doesn't look right, does it? That doesn't look right at all. Something ain't something here. We'll explain involute. Head fillet 0.2. Wait, am I an idiot? I don't think so. That ain't matching up. That ain't marrying. I mean, at some point it is. I just don't know the measurements. You know what? I'm actually thinking that this reversing thing didn't work. I'm actually thinking that this needs to be the flex head fillet. The head. And the root fillet needs to be the flex root fillet. I don't know why, but I'm just going to try. See what happens. Fillet not possible. Yeah, well, the root fillet can't be 0.4, so we know that. So we'll go back to 0.2 with everything for now, just before we can tweak. We'll tweak values later, but I just want to get them parameterized first. Right, 0.2. That's because of the pressure angle. The question is if you push this in, how far is it going to move before these edges touch, right? So it's like that distance there is less than that distance there, which is, but is it enough? Anyway, yeah, I'm okay. I don't quite have this right yet, but I just want to parameterize these things for now. We've also got the base gear as well, which I need to parameterize too, which is a bit of a pain not knowing which way around to do it. So I think okay, what else do we have to do? Let's base all this on the flex spline. We want the flex spline. I think I need to get the flex spline right first. I need to get that looking how I think it should look, and then I need to match the outer gears to mesh with the flex spline. I think that is, to me, seems the most the most best way to do it. Undercuts. I can't remember what that means. I'll take it and see what happens. God, it takes a while to recompute, eh? Root fillet is not allowed if undercut. Yeah, okay. So backlash, clearance, head, head value times module value equals additional length of head. So really what I want to do is I want to add a flex. We'll go flex head value, and it's going to be I think it's just a float. So we're going to go minus 0.6, and I think we need to make a group. We're going to rename property group. I don't know if you can you actually create a group after, like, can you move these? You can. Beautiful. Okay, that's good. Yay. So we'll get general gear parameters. Why can't I? What? Rename property group? Hello? Why can't I do that here? Okay. What? Base module. Outer teeth. Pressure angle. Huh? Alright, that's weird. Rename property group. We'll call it gear. We'll just call it gear. And we'll go that one, that one. Yeah, it's weird. You can't do control click. And you got to click in here to rename. What? I don't get it. I want to rename property group of this one, but it's not letting me. Weird, huh? Why not? See, I can on that one. Strange, isn't it? There was some weird... I don't know if that's a bug. I mean... put that in there. Base module. See, I want to put that in the... Why can't I rename group on that one? Kind of weird, man. I wonder if I rename it. And now I can? What the hell? Okay, that's pretty weird. I don't know what was going on there. Anywho. That's part of Flex. So this is beautiful. I mean, I do really like this ability to have variables and then have subgroups for them. That's quite lovely. Quite lovely. So the other thing I was going to add was the flex head value. So we need to go to head, and we're going to go variables flex head value. Right, we're going to see how that changes things. Yeah, so that shortens the head quite a lot, which is what I want to do. I want this quite shallow. So let's go back to variables, and we're going to make that even minus 0.8. Whoops. Why do I do that all the time? I'm going around the wrong way now. Oi, oi, oi. Okay. Minus 0.8. That's better. All right, so now I've almost got this flex spline gear looking like I want. So let's go flex head fillet. Let's increase that to 0.6 and see what happens. I have a feeling that... yeah, I know what's going on here. I can't just match these fillets. Because I can't. Yeah, I kind of know what's going on here. Hard to explain, but if there was a way to pull the root up, I'm not sure. Let's just see if we can go output rotor involute and see what happens when we change the head here. If we go from -0.4 to -0.8, yeah, I'm really not that. That should be. Yeah, of course it's not going to work. It just all looks wrong. It just all looks very wrong. I mean, I'm just going to put these back at 0 and see what happens. If I just go reset 0, reset 0. Okay, so we've got no fillet there. So what is gonna happen? And we've got this clearance as well. All right, so clearance, we've got backlash, which is basically the clearance on the edge of the tooth here, and we've also got clearance, which is the excuse me, the depth clearance. So I think I might put that in here as well. We might go gear clearance. We're just going to go length, and we're going to go 0.1 millimeters and see what happens there. That should have been in gear. Gear clearance 0.1. Let's go internal involutes, and we're going to go down to clearance, variables, clearance, flex to gear clearance. That's not the same. That's a badly named variable. That's better. Okay, so yes, that clearance was pushing the base of that down. Something makes me, I haven't applied the angle to that yet as well, so that's putting me off too. Output rotor. Maybe I have. Or am I looking at the wrong one? I'm looking at... Jeez, this is so confusing. Base gear, let's turn that off. So, yeah. So that angle... As it turns, that angle will roll on there. Alright. So I need to fill it the inside of here. I think this is coming. I think I'm starting to get it now. I mean, a part of this is I need to print it and see what happens. So we go. I do feel like the fillets should match. So maybe having two different fillets is not the best way. I think we just go gear fillet. So I think we go gear fillet, and I think we move this to gear, and we just apply the same fillet across the board. It's going to keep things a bit more simple, which is good sometimes. Where's the fillets? Hello? They're hiding from me. It is a conspiracy. Where are they? Fillets. There we go. They are hiding. Hey, wait, what? Oh, yeah, I deleted those. So variables. Well, no. Yeah, gear fillet. Why is it still coming up with flex head fillet? I'm not sure. Anyway, root fillets. Variables. Fillets. Fillet. Lovely. Lovely, lovely, lovely. Okay, now we're starting to, now I'm looking more like the teeth that I wanted to see. It's like this there's a interaction between the fillet and the pressure angle, which is kind of interesting. Yeah, okay, let's go flex head fillet. Let's just go gear fillet. Oh, it's because I haven't deleted that yet. And then we've got gear fillet here as well. Oops, what am I doing? Clicking all over the place. Okay, so this should now reduce these fillets. And I'm going to go up to 30 degrees pressure angle. I'm going to delete that unneeded head fillets, delete property. We're going to go pressure angle. We're going to try 30 degrees and see what happens. Fillet not possible. Yeah, so see if it is possible. 0.2. That's interesting, hey? Look at the tooth profile here. It's kind of weird, hey? It's like there is like a bulging out of the tooth there. I wonder if, does the fillet... That's crazy. I didn't know it did that. Is that it? Huh. Okay. I'm really interested to see if this actually works, because it feels very mismatched. Like, obviously that's not going to push right into there, but the distance that this has to push in, this doesn't make any sense. Like, I mean, what I could do, I could just transform this just for my own sanity and just push this in here. Yeah, right. Okay, so there is... So, well, like, what's that distance? It doesn't look... This doesn't look right at all. I don't like it. I don't like it at all. That distance is not going to be 1.435 mil. Yeah, this is all kinds of screwed up. So the flex spline I've almost got looking how I want it to look. And I think I do need the head fillet. I think I... Oh my gosh. I think I do need the head fillet. Because I want the head of the flex spline to be nice and round. Alright, so that should make it nice, a nice round... Yeah. That's more the tooth shape that I want for this. I feel like it's going to work better. So just with a bit more playing around, if I go transform, let's just rotate this by like... let's rotate this by the pressure angle. No, we won't actually. We'll go... So pressure angle 30 degrees. We're going to look... I want a side where these things match up roughly. Like a parallel. So it's going to be a bit of playing around. Not where the tooth meshes like that, but where the angles of the sides are about the same. getting further away here. See, that's... It won't be at exactly the point where the teeth mesh. It'll be... I'm feeling like it's somewhere around here. So if I go like this... Right. Maybe it is. Maybe it is there. Wait, are my pressure angles different? Why do I feel like they are? Just want to put this back in the middle. Just undo everything I've did. Good English. Undo everything I've did. Right, we got this involute here. We've got the... So we've got the pressure angle set on the flex spline. We've also got the pressure angle set. I don't know what shift means. We've got a nice looking gear, how I want it looking. Now this also needs to look sort of the same. So I'm thinking, actually, you know what I'm thinking? I'm thinking that it's not... Like, this head value is not helping us on the output involute. I feel like that's the issue. I feel like it's this root that needs to come up, not... And I don't know how to do that. I don't know if you can do that. Maybe it's the clearance. So, like, imagine if I put the clearance to variables head value. Sort of. That's actually pretty good. Like, that's more like what I'm talking about. Now I'm just pissing around. I'll just divide by 2 and see what happens. Love it. See, that looks pretty good. And then we go root fillet. We're gonna go variables head fillet. Match it to there. I think that's it. I actually think that's it. So now if I went like this head value and I made it like -1, huh. I think I get it. I think I get what's going on here. This is great. Okay, so that means what I can do is I can go, right, bear with me here, 0.6. 0.6. And now I want to bring this in. So basically on the I want to like reduce the tooth depth by that. So I'm going to flex head value this one. We have got the flex head value used here, divided by 2. And then the head okay, change of plan. We're just going to use 0.3 for the flex head value. so many numbers here. It's crazy. Minus 0.3. Okay, so we'll do that. And then we're going to apply that 0.3 to both the clearance and the head. I think that'll work. I have a feeling like this is going to screw it up because we can't. Yeah, fillet not possible. Okay, so I mean, what I could do for now, just to get this thing working, is just take away the fillet. I'll just go 0. Is it still complaining? Yeah, it is. Okay. That's all right. I'll go through and finish all the application of this now. So the head flex head value is going to be that minus 0.3. We're going to go to, I reckon we go back to pressure angle and we change that to 20 degrees. We'll just make life easy on ourselves for now. Right, and then we'll go flex spline involute. We'll go down here. We've got the clearance, which should be variables head value. That's going to push that up. Yeah, nice. Okay, this is good. This is good. Right, now I can really see the backlash now. But we've got this difference. No, we don't have a difference in fillets. This is interesting. If I push this in. Okay, yeah, so you can see it's meshing pretty well. But there's like a 0.2 mil gap. Which is what we wanted for backlash, or it's what we set for backlash. It's not what we want. But then I can adjust the fillets on here as well. So we basically want, I said I want the root and the tooth to match. Is that still what I want? I think so. So in this one we're going head fillet. Flex head fillet. Gear fillet. Yeah, so we're just using gear fillet around across the board now. I think. Gear fillet. So this will all be nice and square. And then variables 0.3. So head value negative, let's see how far we can push this, negative 0.5. That should make this a lot. Squatter, that's it. Oh, that's exactly what I'm after. That is perfect. Alright, now we're going to go add property gear. We're going to call it backlash. And we'll give this 0.1 mil. And we'll go through and we will apply that backlash value across here. So we're going to go variables, backlash. And flex spline backlash as well. Now let's watch how this changes. That gap between there should get smaller. Yes, perfect. Oh, this is great. This is absolutely spot on. This is good. Crazy though, like the actual amount of backlash here. Like, I don't know, maybe that's just I think it's just the geometry's playing with me, the way it meshes together. Yeah, that's not bad. It's pretty good. I mean, look at that. Outer gear is basically fitting exactly in there, which probably, you know, isn't great. That's going to be a pretty tough sell to get this working. So maybe that backlash needs to be, I mean, the one thing I'm not sure is, does the backlash need to be applied? Like if I go 0.1 mil translation, we can get this a little bit more accurate. Yeah, so there we can see the backlash in there. That little 0.1 mil gap. So I want to measure that. No, not total length. I want distance. Thank you very much. I want distance between the faces. Yeah, it's going to be tricky. There we go. No. Okay, for God's sakes, can you just give me like a minimum distance? That's what I want. Apparently not. Minimum distance. No. That ain't working. I want distance between faces. I mean, 0.169, that kind of makes sense. We're approaching point. No, it doesn't make sense at all. That's not measuring anything close to what I want it to measure. Ay, ay, ay. So let me go internal involute, because I reckon if we reverse the backlash on this, hello? Watch it carefully. F5. Yeah, no. Yeah, nah. I think we had it right. And then with the flex spline, I assume it's going to do the same. It's going to make the tooth wider if I reverse the backlash. Yes. Okay, good. No, so we're good. We're good. I mean, I might try it with 0.1. I might try printing with 0.1. It's 0.2 total on the tooth, I think. Is backlash? I don't know what that means. It's the total clearance between the meshing of the two gears. The total amount of free rotational movement possible for one gear. So that's 0.05 each side. So that's not what I want. What I do want is, because of this is mainly because of 3D printing, my crappy 3D printer. What I do want is 0.2 total clearance. Yeah, that's going to give it a much greater chance of success there. So flex spline, I want to get this back into the center again. Cool, cool, cool. Now, I did have a bit of a problem with the clearance here being too tight as well. So I want to adjust that. Now, I'm not sure if I've got anything in here that I've made already, which I can... Wave gen base thickness. So that's that, right? Oh my gosh. I can't, like, this annoys me so much sometimes. I don't know what's going on. Oh, it's because this overlay thing in FreeCAD is so annoying. Like, it acts like there's something there blocking your mouse clicks, but there isn't. It's a pain in the butt. So many I complain all the time, but 4.05 mil. Yeah, so all my thickness calculations and everything are not working. They are all totally screwed. And part of this makes sense now because I wasn't taking into account the clearance and head. So like some of these things here, this is not correct either, like the stretch. All of these calculated things are not right anymore. Because it's the root diameter, and we've got to take into account the clearance. So, right, so we got, so the internal involute gear is this one. So the root diameter is going to be out here somewhere. And what we need to do is minus or add the clearance. I wish you could multi-line in this. Variables, gear clearance. Flex head value. Is there a way to put units on? I'm just totally guessing here. I don't know. I don't think there is. So it was something to do with the modulus, though. I think it said it's not that simple. So if we look at the head value, it is head value times module value, additional length of head. Head value times module. Okay. So we can put that in here. So we can go additional head length. And that is going to be variables head value times variables base module. Result unit mismatch. So there must be some kind of typecasting. FreeCAD formula. Casting. Casting. Expressions, that's what they're called. My dimension times 1 millimeter, 1 dig. Use the Python modulus to drop units. Flex head fillet. I don't get why that's not working, because flex head fillet is in oh, maybe it's not. Yeah, it is. But we're using gear fillet. So I don't know why I can't use that, because I want the output in millimeters, which is fine, and we're going to call this additional and it says it's based on the modulus. Oh, the modulus is the module is in millimeters as well, which is fine. See, gear module 2 millimeters times variables flex head value. Yeah. Now it works. I don't know. Anyway, additional tooth length. So now we can go calculated. Now we can do this stuff. Now we can go stretch is root diameter, involute gear, addend diameter minus 2 times calculated additional tooth length. Stretch is 5 mil. Still doesn't sound right, does it? Output rotor cap thickness. That's not what I want. So that distance there is what I want. That distance between those two lines. I want minimum distance. Distance between two faces. Use the measure tool, select two faces, shortest distance in the exact perpendicular, activate the tool. Yeah, okay. At least it does. Is it going to work this time? 2.05. I mean, it's not completely wrong, is it? But the stretch should be 4 mil in that case. Should be 4 millimeters. Unless I'm just being dumb. 1.953. Yeah. So I don't know. I could be just completely messing. I don't think the stretch is I don't think the stretch is actually so thinking about PEMDAS, the order of operations, multiplication first, so it's going to go 2 times additional tooth length. Maybe that's it. No, that still doesn't make sense. Well, there's 4 mil. I mean, okay, let me think about this. What do we have to allow for? We've said it is the... We need to find out the stretch on one side. So if we go like... Okay, I'm going to go crazy here. I'm just going to go... a bunch of brackets. We're going to go root diameter divided by 2. So that's root radius minus addendum radius so we've got the internal involute gear root minus, which is back here, minus addendum, which is there. It's going to give us the gap between the flex tooth tip and the involute gear root. And now we need to adjust for the clearance. So we're going to add the additional tooth length. Which is minus, like, whatever it was, minus 1 millimeter. Okay, I'm just going to chuck that in there for now. Take stock of where we're at. I can't, it's so hard to visualize this. I should draw a diagram, really. 2.045 is the value we're actually after. I mean, I could just make that a measurement rather than trying to calculate it, but I'd love to know how it actually works. It's just probably not, it's just probably simply not that simple. I'm just guessing. What am I even doing? 2.167. Yeah, no, we're just... I don't know. I mean, I could go to paint. So we've got that. We've got that. So that is root radius. Addendum radius. Oh my gosh, come on. What? Can you just let me actually, like... How do I say, yes, I accept text value? Click outside it. Alright, that makes sense. Root radius. Okay, we need a smaller text as well. 72 is a bit ridiculous. So we got, in theory, we've got root radius minus add radius equals gap between tip and root. Sounds dirty. Okay. But then we've got additional tooth length. Then we've got additional tooth length, which is here. Additional tooth length. But at the same time, we've got additional tooth length here as well, which really just offsets everything by that much. But it's probably not exactly the same because it doesn't... The modulus on both is the same. So if the modulus is the same and the additional tooth length is modulus times the head value, then I don't see... But maybe the clearance is different. Maybe because one of them's clearance and one of them's... That's probably what it is. So I wonder if we can see what the clearance works out to be. Radial distance between the tooth tip of one gear and the tooth. You can easily adjust the clearance and backlash. Yeah, so clearance. At a gear pair, clearance is the distance between the tooth tip of the first gear and the tooth root of the second gear. Yeah, okay. I feel like that's where I'm going wrong. I feel like actually doing a measure might be... Wait. Yeah, a measure might be the way. I just want to see if... Yeah, 1.983 along the y-axis. Yeah, 2.045. Okay. Alright, I'm going to be right back. Okay. 2 mil. I don't think I'm going to get the value. I don't think I'm going to be able to calculate it. I think there's just something fundamentally wrong here. But I mean, I can get 2 mil, and then I can change some things, and I can see if it matches up. So if we go plus additional tooth length minus additional tooth length divided by 2, or plus. Okay, seems a bit weird, but see if my logic works. Right, so now if we go variables and we go flex head value minus 0.3. .2. Now, did that actually increase in distance? It's not going to be exact, but 2.068. A little bit, but not much. Not 2.2. Yeah. Well, the other way to find out is if we go like, if we go variables and we set the head to 0. And then we measure that to that. 2.101. It is changing. Now it's pretty much the backlash value. What? Doesn't make any sense. Why is it saying? What? Minus flex. Wait. Internal involute gear route. Involute gear dot. Maybe I just had the wrong. I think I'm an idiot. I think I just had the wrong values. That's it. I mean, that's it. 2.105. Awesome. Okay, but we don't need to divide by 2, so... Okay, oh man, I was just using the wrong part. That's so stupid. Oh well, that's what happens. So yeah, the distance between these is 2.105. Oh, they're close enough. Close enough. It's good. It's good. Alright, so let's go back to variables. Let's add this head value back in of minus 0.5. Hello. There we go. Minus 0.5. And now the calculated 4.105, which is 2.05, which is roughly what we saw last time, wasn't it? 2.045. We got there. We got there. That's good. All right, save time. Save time. Okay, this is going to work so much better than the last one, I've got to say. Right, now we can do some other adjustments that we need, that we've screwed up. So now we know roughly how that math works. This, we can fix this. So the distance along here is currently 4 millimeters, which it shouldn't be. So base gear body thickness, we've said gear root to outer thickness. Got some of these names. Some of these names are not good. So it's this thickness here. So I think I know how to do this now. So we're going to use the root diameter. We're going to use the root diameter, and we're going to add to that the clearance value to go in. Oh, but that needs to be the, it's calculated actually, so that's that tooth, additional tooth length, minus addition comes before subtraction. So, wait, hang on, I need to get this around the right way. I don't know if it matters. I'm just going to go variables, root to outer thickness. Yeah, okay, so this definitely isn't right. Root diameter. We want this divided by 2. So we get the root radius. And then we are going to Maybe it's not that complicated. Maybe it's literally just... Maybe it's just this. Wait, what? Oh my gosh. Additional tooth length plus I doubt it. This doesn't seem right. But I'll start there. Yeah, okay. Maybe minus. Invalid each link, yeah, because that's going to screw up the geometry totally, so... -4, that's not what we want. Maybe it's the other way around. Oh my gosh. Frickin' autocomplete is so annoying sometimes. Okay, minus. 4 mil. All right. Now, we wanted that distance to be 3 millimeters, I think. And it's 2.96, which is pretty damn close. I'm gonna say close enough. 2.943. That's really, really close. But 2.96 is very close to 3. I'm pretty sure that's gonna be good enough for us. It's 2.96 all the way around, isn't it? So what I should be able to do is adjust the, let's see if we've, let's go close. Let's see if we've actually set this properly. We've got gear root to outer thickness of 3 millimeters. So if we adjust the head value to like minus 0.2, wait for it to re-render. It does take a little bit of time, doesn't it? Okay. Yeah, see, that's reduced now. Oh, man, this is so frustrating. Okay. It's because I'm just guessing. I'm not really thinking about it properly. So, gear root. No, it doesn't make sense to me. I know it doesn't work. I know it's wrong, but I just, so let's stop guessing. I was talking to myself. Now rubber ducking it, they call it. What are we actually trying to work out? We're trying to work out the distance between the root and the outer here. Okay, we want to set that to 3 millimeters. Using this value, thickness. The problem is I don't know what thickness actually means. So if I maybe go reset, let's see if we can figure out what thickness means. If we can go like 1 millimeter. Right? Maybe 3 millimeters then. Okay. There we go. So we've got 3 millimeters. Now, let's go to variables and set flex head value to 0. And let's see if anything actually measures at 3 millimeters. Definitely not that. What about this? 5 millimeters. Some number adjacent to 5. How do I change the settings of this? I don't know. Does this number marry up with anything else? .901. 0.901. Let's have a look. Let's ask AI and see what happens. Usually not a tooth geometry parameter at all, is the radial thickness of the ring gear body outside the tooth root circle. Yeah, but it's not. For an internal gear, the tooths point inwards, so there are 3 important diameters. Tip diameter, where the tooth tips are, pitch diameter, taking the root diameter and then adding the specified thickness outside of it. I don't think so. I don't think so. So outer radius equals root radius plus thickness. Tooth tip to outside wall, you'll get thickness plus tooth depth. Root valley to the outside wall, you should get... No, I don't though. That didn't help me at all. mean, okay. Got another test. Let's see. What this distance is. X. No, see, that would be longer than 3. It's not that. It's not the tooth depth. Of course it isn't. Why would it be? It's not that. I feel like we're only getting these kinds of values if we use this addendum diameter, right? Or the root diameter. So what value are we getting here? We're getting 0.901. .901. So what if we go root diameter minus addendum diameter? We get 84.211 minus 75.789, 8.422. Nope. What about the other way around? What if we flip it? What if we go addendum diameter 75.789 minus root diameter of 84.211? Of course, we get the opposite number, and then we add 3. That doesn't work either. What if we go... So, what if we go pitch diameter? 80 minus 75.789. 4.211 minus 3, we still get 1 point. We don't get there. What about what about I hate this. I hate guessing. I hate it. It is so annoying. What the hell is transverse pitch? I need to know that. I need to know things. The distance between the center lines of adjacent rows of is the arc distance between corresponding points on adjacent gear teeth. Right. I see. Right. Okay, well that makes sense. That makes sense. I don't think it's anything to do with what we're looking at here. I don't think. Could well be, you know. Right, so we got... Wait. So outside diameter is pitch diameter plus 2 times the thickness. Okay. Yeah, which makes sense. Outside diameter equals pitch diameter plus 2 times the thickness. Okay, so therefore the root so pitch diameter to minus addendum diameter. Yeah, okay, so we're going to go root diameter minus pitch diameter. Root diameter is 84.211 minus 80. 4.211. Now, that is the distance I got it. I got it. I got it. I have got it. I need to add this value to the thickness. Anyway, I gotta go.